Assalamualaikum and hi. I back to my respected lecturer, Professor Madiati S. Dr. Roslina binti Muhammad and fellow classmates. My name is Muhammad Hazid and I am representing Group 3 from class EE2234B and our group mini project title is IoT Home Monitoring System in Malaysia, which we developed alongside with my members Hamdi Rahman and Ahmad Muizuddin. Rapid development has made home environments the topic of human health, meaning Malaysian household must monitor utility safety, climate indicators, and nearby environmental hazards. Internal issues like sudden high or water electricity readings can indicate causing pipe leaks or malfunctioning appliances that pose fire risks, while external factors like regional air pollution and weather changes cause poor indoor air quality, triggering coughing, eye irritation, and respiratory complications for vulnerable members. Because these safety indicators change dramatically by state and throughout the day, homeowners need a centralized view of their regional statistics. However, most public information is currently hidden in separated raw data sets across different government portals, leaving regular citizens unsure how to protect their families or whether to minimize the heavy appliances usage. To bridge this critical gap, our project used the IoT to fetch open source open packet data and real-time residential indicators, specifically air quality, water consumption, and regional electricity grid parameters, using localized data APIs from Department of Statistics Malaysia. This data is dynamically routed to a centralized IoT dashboard that presents the air pollution index AP, particulate matter, water trends, and grid stability using highly visual graph, gauges, and comparison maps. Finally, the system applies the data analytics to group these streams into distinct safety thresholds, allowing it to provide intelligent recommendations tailored for Malaysian households, such as advising residents to save windows and run indoor air purifiers when regional pollution spikes, or alert them to audit home appliances if localized electricity grids show extreme peak load warnings. I want to discuss the critical problems that motivate our project. Rapid urbanization has made our homes the center of human health. Yet, Malaysian households face severe hidden risks from both domestic utilities and external environmental hazards. First, on the domestic front, sudden spikes in water or electricity are the earliest indicators of danger. For instance, undetected water leaks cause dampness where toxic mold can multiply in just 1 or 2 days, severely compromising our respiratory system. On the electrical side, data from Bomber reveals a staggering statistic. Electrical fault like circuit overloads are the leading cause behind over 60% of structural fires in Malaysian residential premises. Beyond internal threats, external hazards like seasonal haze and particulate matter easily penetrate our homes. Long-term exposure in Malaysia is linked to thousands of premature deaths annually from strokes, lung cancer, and heart diseases, acting as an immediate trigger for vulnerable family members like children and asthma sufferers. Because industrial density and weather vary by state, this risk level constantly change by the location and peak daily hours. Unfortunately, a massive gap exists in how this data reaches the public. Current environmental and utility data sets in Malaysia are raw, complex, and scattered across separated government portals. Homeowners might see a rising air pollution index or a surge in grid demand, but they lack actionable awareness. They simply do not know what precautionary steps to take. Our IoT system bridges this gap by acting as a uniform medium. It combines and analyzes and translates raw water, electricity, and air pollution data into clear, simple warning indicators, moving Malaysian homes away from raw data and toward proactive, real-time safety. Here is our group objective. First thing first, we want to collect water consumption, electricity, and air pollution data in Malaysia from reliable sources. The second thing, we want to develop an IoT dashboard that monitors water consumption, electricity, and air pollution using graph, gauges, and maps. Third, We want to integrate artificial intelligence that analyze water consumption, electricity, and air pollution data and alert users.
This is the block diagram for our project. We collect data from OpenDOSM catalog and then using Python programming on Jupyter to extract and process the data. Then all the data will be sent to ThinkSpot for monitoring and Telegram for alert. This is the main program. It will first initialize all the constant, APIs, tokens, and interval. Next, the program will define the dataset dictionary with API URLs from OpenDOSM. It will then pass through the load data function and filters only the wanted data from all the collected data. The filtered data then being sent to detection group anomaly, which is the AI, to detect any abnormal spikes in the data. Next, the program will do a calculation for sending interval for each data since the data has different volumes. This is to ensure that at the end of the data sending, all the data will loop together. The water, electric, and pollution key is to rename the sent data to be easily recognized in ThinkSpot. The set data function transmits metrics to ThinkSpot and alerts to Telegram. By using threading, the program runs this function for all three datasets at the same time. This means each thread works independently, ensuring that one slow connection doesn't block the others from sending in their data. After all the data being sent, it will repeat itself to simulate real-time data collection. Load data function will read all the data from the paraquet into a data frame and converts date from string to date-time format. This function will also ignore the empty value and then return it back to the main program. The detect group anomaly function is the AI, which is used to detect data spike or anomaly. If the AI detects spikes in data, it will update the status of that specific data to abnormal and then send it back to the main program. Water, electric, and pollution key is to rename the data before sending it to ThinkSpot. Set data function is to send data to ThinkSpot and alerts to Telegram as mentioned before. If there are any abnormal data from the AI status, the program will send a signal to the set Telegram alert function. The data will also be sent to ThinkSpot whether it is an anomaly or a normal AI status data. For the ThinkSpot function, it sends the data to the URL using the host domain and token generated from ThinkSpot. It will also print status code in case our data could not be sent or there is any error with the packet file. Set Telegram alert function will send a message via Telegram bot. It also uses Telegram API URL and chatbot ID.
Okay, now we are gonna run our code. Our code have data collections, data processing, data transmission, and also AI integration, which is use anomaly detection. Here we can see that our data is being sent to the Telegram and ThinkSpot. We use Visual Code Studio and port it to Jupyter using Jupyter extension. From here, we can access localhost, which direct us to Jupyter Notebook on the browser. Now we're gonna see the Jupyter. This is our Jupyter notebook, and this is our coding. We're gonna go through this, and then it's the same thing. The data is gonna be sent, but we use extension on the Jupyter to Visual Code Studio. Now we're gonna see the things about the dashboard. After the data is being sent, we can see that the electric consumption and air pollution, the data is already be sent, like the electric consumption, carbon monoxide chart, nitrogen chart, and the gauges. You can see the electric consumption now is about 2685 kilowatt, maybe 28342 because that is the average. We can see at the electric consumption, but we can see at the chart when we move our mouse to the chart, we can see the exact value. And for the carbon monoxide, this now is 0.615. Same with the gauges. And for the nitrogen dioxide, we can see the value is 0.008. And we can see also see the level for each data. Like the electric consumption chart is now at green. For the carbon monoxide is kind of yellow right now. And for the nitrogen is more to orange. Now we're going to move to the second dashboard, which is water consumption. We have six thing in this dashboard, which is we divide the data, which is we have 15 data for this one. Because we are using state data and also have Malaysia, so we separate it by the region. First, East Coast, West Coast, Northern region, Southern region, and Borneo. And last one is Malaysia. Now we can see the data is being sent. The Kelantan, Pahang, Terengganu, Negeri Sembilan, Melaka, Selangor, and the Northern, Perlis, Kedah, Pulau Pinang, and for Borneo, Sabah, Sarawak, and Wilayah Persekutuan Labuan. And for the southern region, we have Johor, and for Malaysia, we have Malaysia itself. So the data is Kelantan right now. We are using the unit is cubic meter. Now we move the last one, which is map in the dashboard. This is our map. Our map have the data itself. When we're clicking the marker like Pahang or Malaysia or Wilayah Persekutuan, it will show the latitude, the longitude, and the water consumption domestically at that place. Uh, we have some error here because our capture cannot capture the data that being clicked. But when we click the data, when we click the marker, there is data there. But for Malaysia, it has more data since our data is more all local to Malaysia, like the electric consumption, the air pollutions, and the water consumption domestically. Then we are done. And after done with the dashboard, we're gonna see the last one, which is our telegram. After the AI is detecting the anomaly in our data, it's gonna send the warning to our telegram. As we can see here, we have the local domestic, and now it's still sending the warning, like the consumption, the local domestic, the concentration for our air pollutions, and also there is for water distribution also. And after that, our system is done. Now we're gonna add a dashboard. So before we add a dashboard, we're gonna have a device. So we get to device tab and add the device, put a name, mini project, and we're gonna see the credential, which is the access token to put in the Python. Then we go to the connectivity. So we to have the ThinkSpot host cloud to put in the Python so that we can transmit data into ThinkSpot. After that, after done, we go to dashboard. We have three dashboard for more organized. So we go to the first one, which is electric consumption and air pollution. We have three charts and three gauges. How to add charts? We go to add widget and then choose charts and time series chart. After that, we're going to see the setting for the chart. We're going to see the first example for the domestic electric consumption, how to set up. First, select the device and then put the key for our data, the label, and the units. After that, we save. Then we go for we have the charts. Then for the carbon monoxide chart, it's the same. For the nitrogen dioxide, also the same step, just different color. So we're going to go to the gauges, add widget, digital gauges, and click digital vertical bar. The setting for it is gonna be different, but we're gonna see the setting for the digital vertical bar for the electric consumption. First, we're gonna see the same step at the device, at the data key, but a little bit different. We have minimum and maximum for the threshold and the color, which is start from the green and red, so that when the data is increasing, it will go from green and red. The data for carbon monoxide and nitrogen dioxide is the same step. After we apply and save, our first dashboard is gonna be done. After that, we're gonna go to the second dashboard, which is water consumption. It's been divided to six chart, which is the some region of in Malaysia, which is East Coast, West Coast, Northern region, Southern region, Borneo, and Malaysia. The same step for chart before, we're gonna see one example, which is the East Coast. It's the same step at the mini project and the data key, which is Kelantan, Pahang, and Terengganu. After that, click save and we go to the last one, which is map. Before we add the map, we have to have some setting, which is we go to device for the longitude and latitude. We go to attributes, server attributes, and we add the latitude and the longitude for the place that we want to put in the map. After that, we can go back to the dashboard map to add the widget plus the widget, and add map for the widget map we want to use. Then we're gonna see the setting for the map, which is the map already been done. We're gonna see the setting, which is add mini project, the longitude, the latitude for the one we were going to use. We go to market configuration. We want to add data, so add the additional data key, and this is the name for our marker, which is Johor, and this is how our want to display the data. After that, same step for other states. Then after that, our map is gonna be done. Now we go to discussions. The home monitoring system successfully utilized a Python script to retrieve data from the OpenDOSM API, filtering out irrelevant commercial metrics before transmitting the refined data to ThinkSpot for visualization via gorgeous graphs and maps. Also, employing an anomaly detection algorithm to send real-time warnings alerts to Telegram. However, the implementation faced three primary challenges. First, data inconsistency. As water consumption data covers all Malaysian states, while electricity and air pollution data are restricted to national levels only. Second, timing disparities. Where the sortings and filtering processes introduce minor latency and uneven transmission intervals. And the last one, Telegram alert management, which broadcasts all state notifications simultaneously without options for regional filtering. But despite these constraints, strategic workarounds were successfully integrated to optimize the output, rendering the system fully functional and complete.
This project can be further expanded by using live sensors instead of parquet database. By doing so, data latency will be eliminated and true real-time situational awareness will be provided to the ThinkSpot dashboard. Furthermore, the current reactive anomaly detector should be replaced by a predictive LSTM deep learning model by shifting the focus from identifying past error to forecasting future time series trends. Proactive Telegram alerts can be dispatched to warn users of impending utility overload or pollution spike hours before a threshold are actually reached.
In conclusion, our team successfully executed all three objectives for IoT home monitoring system in Malaysia. A validated data foundation has been built by extracting raw real-time packet dataset for water, electricity, and air pollution directly from the government's open data platform on DOSM. Second, the data is transformed into interactive IoT dashboard utilizing the ThinkSpot cloud platform. This development enables live visualization through intuitive widgets including historical graph, gorgeous geographical maps, and administrative drastically simplifying complex trend analysis for the average user. Finally, artificial intelligence has been integrated into the core system using the isolation forest algorithm to process and detect anomalous utility and pollution patterns. The moment an irregularity is flagged, a dynamic rule change automatically dispatched instantaneous warning alerts directly to user's smartphone via a Telegram bot. Ultimately, this project proved how raw telemetry can be transformed into proactive real-time insight by converging cloud visualization, automated machine learning, and rapid data pipe learning. By evolving from a passive tracking tool into a responsive decision-making framework, our architecture delivers a highly scalable blueprint for modern smart home management, public health, defense, and intelligent resource optimization in Malaysia. Thank you very much, Dr. Roslina, and everyone for your time.